It says if the expression 5x squared minus 4x plus 1 divided by x minus 2 is written in the form 5x plus 6 plus b over x minus 2, where b is a constant, what is the value of b? Notice that if you pay attention to the form of this expression, you have here a polynomial of degree 2, here a binomial of degree 1, and this yields this expression, which is one polynomial plus a constant over the original divisor. This format only corresponds to what we saw originally, okay? To this here. So if we see a constant divided by the original divisor, it means that everything prior to it is actually the quotient of the division. So what do we have here is actually the divisor of this, the quotient of the division. And here, this one is the remainder of such division divided by the divisor. So they're asking me to find the remainder. How can I find the remainder? Obviously, one long way to do it is to do the division itself. Same way we've done the previous ones. But can I actually get to find the value of b without having to do the division? Yes, we can. How is that possible? If we apply the remainder theorem. What does the remainder theorem say? That if it is clear that in a division of a polynomial by a binomial of this form, you get a remainder, which is a constant value, then that remainder is exactly the result of evaluating the polynomial px, which is this expression, the dividend, evaluating here with a value of x that makes the divisor 0. So what value of x makes this part 0? Can you tell? Which x makes that 0? Not so hard, right? Yes. Then you know that if you evaluate the polynomial on value 2, constant value 2, what you get as a result, that is p of 2, is actually the remainder of this division. In other words, the value of p. So this is much faster. You can say simply, okay, p of 2 would be 5 times 2 squared minus 4 times 2 plus 1. Okay, this is 4, this is 20. Here we have 8 plus 1. What do we have? Okay, 12 plus 1 equals 13. This is it. Is that really so? Let's verify. Take a look. We are doing the whole division, okay? So that you can verify how this works in all cases. 5x squared minus 4x plus 1 divided by x minus 2. Notice that by doing the division, we will be able to identify what is the quotient, which is this part, and what is actually the value of b, the remainder. Take a look. 5x squared divided by x. Easy, right? 5x. Now multiply 5x by x minus 2 and subtract it from the original polynomial. So let's do that. 5x times x, here subtracting negative 5x squared. 5x times negative 2, that is negative 10x, but we are subtracting, so change the sign, 10x. And that's it. Let's do the subtraction. Here you have 6x plus 1. We just drop this other term. Okay, 6x plus 1 divided by x minus 2. Again, pick the first term and divide it by this. 6x divided by x equals 6. And multiply this 6 by x minus 2 and subtract it from this part. So 6 times x, negative 6x, since we're subtracting. 6 times negative 2, negative 12, plus 12, because we are subtracting. And so we have 1 plus 12, 13. You see? The remainder. And here, of course, we have the quotient, exactly as in the original or the above expression. So these are the two ways, but here the remainder theorem provides us with a shortcut, okay, to solve this type of question. Remember, whenever they give you a polynomials division where they suggest this form and they ask you to find this constant value, which is divided by the original divisor, which acts as a sort of Q, right? Q to the quotient. Okay, then you can use the remainder theorem.